Hi crew, hope you're doing well. I am making that video I promised you guys. Look at the time, 5:01 p.m. If this isn't a testament to how much I care about you guys and love you guys, remember, I like Starbucks and you know where my order is. With the substitute teacher, you should have already learned how to do directions and how to calculate those directions. So if you guys had this kind of axis, you should be able to know that how to calculate the angle inside of there, being east something towards the north or north something towards the east. Remember, that is your compass point. Another type of way you should have already learned how to do directions is with RCS. So depending on, honestly, doesn't matter where your vector is, you are always measuring from this east axis counterclockwise towards that angle. Remember, each quadrant is 90 degrees. And so for your protractor, you don't even have to measure this entire angle. You can measure this angle inside here and add 90, and that gives you your RCS, okay? So you should have already done that, and you should have also already done a worksheet for this. So if you have not, you're already behind, and I don't know what you're doing. So today you are gonna go through a couple examples with me. You do have these examples in your notes. You should be able to turn to sample problem B. And what I'm going to do is I'm going to walk you through some vector addition problems, doing sample problem B and sample problem C with you, and then you guys are going to do some work on your own, okay? So when we do these sample problems, what we're doing is combining vectors, the drawing of vectors and drawing and adding them together like we have done on previous worksheets. And we're also combining that with measuring direction, because remember, vector, the Despicable Me guy, is magnitude and direction. So if we look at sample problem B, I'm going to walk through this with you. Please write this down as we go. But the problem says a man walks 8 blocks south and then 6 blocks east. And it's asking what is the resultant displacement. Okay, and we're supposed to use this using vector addition methods, meaning we are going to be adding these vectors together and solving for that resultant displacement. Now, what you need for this question is a ruler and a protractor. Okay, if you haven't bought one now, again, what are you doing? You need a ruler and a protractor. Don't keep stealing from me every class. So if we're looking at this type of question, the first step we are going to do is we are going to create what's called a scale factor. Okay, and what I mean by that is we do not have enough room on our page to draw blocks. Okay, so if that's not a unit of measurement that we can draw on our page, we need to use a scale factor. And what that means is we could say that for every 1 block from the question, maybe on our sheet, we are going to draw 1 centimeter. Okay, that's what a scale factor is. And so first things first is we are going to convert the 8 blocks south and the 6 blocks east to a drawable vector on our sheets. So if it is 8 blocks south, then what we would draw using our scale factors is just 8 centimeters south. And if we also have 6 blocks east, then we are going to draw a 6 centimeter vector towards the east. Okay, so this is a very simplified problem. Now, we have to be very, very accurate with our drawing. We can't just draw an 8.2 centimeter line. We can't draw a 6.5 centimeter line. We need to be very accurate with a ruler to actually draw this out, okay? Now, it doesn't matter which line we draw first, but we do need to be very accurate. So using your ruler, let's draw that very first vector. We are gonna draw a vector that is 8 centimeters towards the south. So we should draw a line 8 centimeters, should be nice and straight. Okay, I don't like that. Mine wasn't very straight. But it should be nice and straight towards the south. We need to have an arrow to indicate direction. Okay, and this is our 8 centimeters. Now, using our head to tail method, we are going to draw a 6 centimeter vector going towards the east. Make sure we are drawing this at a 90-degree angle. This should be 90 degrees. An arrowhead pointing towards the east, and that is 6 centimeters. Okay, so this is first what we do, vector addition, head to tail method. Now we want to make sure we're drawing our resultant displacement. So we are going to connect start to finish, and we always draw an arrowhead on our resultant towards the finish line. Never towards the start, always towards the finish. So once we have drawn this resultant, okay, we just need to make sure everything is very, very accurate. So I'll give you a couple seconds to make sure your triangles look perfect. Okay, so this was our step 2, drawing a very accurate triangle with proper labels and proper arrows. Now what we're going to do is measure the displacement. Okay, that is step 3, displacement. Now to do our displacement, we are essentially just looking at that resultant and we are measuring it, our resultant vector. Now to do this, take your ruler and it's as simple as measuring how long that line is. And your line should be, if we think about its magnitude, that's just how long it is, it should be 10 centimeters. If it's not, then that's an issue with your accuracy with drawing your triangle. So it should be 10 centimeters. If you're off by like 1 or 2 millimeters each way, that's okay, but we need to be super accurate with this. Okay, so we've taken our ruler and we have measured, and it should be 10 centimeters. But remember, displacement is a vector value, which means we have magnitude and direction. Okay, so we also need to use our protractor and calculate the direction of this. So I'm going to change color here. And if we look at this triangle, the angle we should be measuring is the angle right beside our starting point. Okay, our starting point is always the angle we should be measuring. Not the finish line, that is wrong. Always the starting point. So what you're gonna do is you're gonna take your protractor and you are going to line it up to measure that angle. I don't really have a protractor, but you should line it up kind of like this. Okay, to be able to measure this inside angle. Once you have done this, you should get the angle to be approximately 36 degrees. Now, when we are measuring direction with our protractor, always, always, always include 1 decimal place. Okay, so it can be a guess, just like we learned when we were measuring, that can be a guess, but I always want us to include 1 decimal place. So maybe your guess is a 0, or maybe your guess is 5. Whatever the case may be, we need to include 1 decimal place. Now, to make sure our direction is proper, we are going to use compass point direction. So that is where we take our square brackets and we include some directions inside of here. So if we are measuring from this very first vector, if I pretend I have a protractor on here again, I draw it on. Okay, the first direction we are going to include is the direction that we laid our protractor on. Okay, so which axis did we lay our protractor on? That is our south axis, okay, because the vector is going down, so our south axis. And then we measured 36.5 degrees that direction. What is that direction? East. So that means my overall direction is south, 36.5 degrees east. So when we combine this together for a final answer, our final displacement, we're going to then include our least count. Okay, because in this case, we didn't times or divide anything. We kind of just added things together. So we're going to use least count here. So our displacement or our resultant needs to have a least count in the ones position. So again, if we look at the numbers we combined, 8 and 6, okay? Both of those are accurate to the ones position. So my final answer is going to be accurate to the ones position. Currently, it is accurate to what position? The tens. And we want it accurate to the ones. So all we have to do is underline, or we can put a decimal, either or. So we are going to say 10 centimeters south, 36.5, 1 decimal place, towards the east. And that is my final displacement. Now, these questions get really messy. So if you love me at all, please box your answer, circle your answer, do something so that it's easy for me to find your final answer. Okay, so this is how we do this type of question. We have a scale factor, we draw our triangle and label it, we calculate our magnitude and direction with a ruler and a protractor, and then we make sure we have proper least count at the very end. And then you box that answer. Okay, so we're gonna do sample problem C together now. So hopefully you had enough time to write this all out. We're gonna do sample problem C. This is a little bit tougher, and you'll see why soon, but we're gonna do the same method. Okay, so sample problem C says, a boy delivering papers covers his route by traveling 3 blocks west, 4 blocks north, then 6 blocks east. Find his final displacement. Okay, so same thing that we did before. Okay, we need to have our scale factor, but can you guys figure out what is the difference between this question and the other question? We have 3 vectors we're worried about now. We have a west, we have a north, and we have an east. Now, when we do these vector addition problems, we always want to use a triangle, which means we actually only want 2 sides to this. And right now, we see we would have 3 different sides. We have a west, north, and then east. Does that look like a triangle? Absolutely not. So what we're going to do is combine vectors. Okay, so if we think about our axis here, we can combine vectors that are going on this axis, and we can combine vectors that are going on this axis. So if we look, we only have 1 vector on that north-south axis, and that is 4 blocks north. We have 2 vectors on this west-east axis, so we can combine them. Okay, so we have 3 blocks west, and we are combining that with 6 blocks east. Now, they are going in opposite directions. We're going west, and then we are going east. So my resultant is the sum of those. If they are going in opposite directions, do we add them or do we subtract them? I hope someone said subtract. Okay, so even though we have an addition sign here, we're actually going to be subtracting them. Okay, and so we would be left with 3 blocks, 6 minus 3, in what direction? East, because the east vector is bigger. Okay, so technically, if we combine them like this and do some math, we should be left with just 2 vectors that we are dealing with. Okay, we should be left with a north-south vector, which is our 4 blocks north, and we should be left with our west-east vector, which is 3 blocks east. Now that I have my 2 vectors I'm dealing with, then I can think about my scale factor. Okay, so we can see I did a whole bunch of math before we actually got to the question. So step 1, we are doing scale factor. Okay, now the scale factor could probably be the same as our other question. We're obviously not going to draw blocks on our page, so we might just write that 1 block from our question, maybe we'll draw 1 centimeter. Okay, and so that means that our 4 blocks north is going to turn to 4 centimeters north. And our 3 blocks east is going to turn to 3 centimeters east. So these are going to be my 2 vectors I am going to draw. And I am going to draw this very accurately. Okay? So if we do this, we are going to draw a 4 centimeter line going north. We are going to label that 4 centimeters. And then we are going to draw 3 centimeters towards the east. 3 centimeters. So remember, this needs to be a 90-degree angle. Don't butcher this part. Now we are going to draw our resultant, and our arrow is always pointing towards the finish line. Okay, so your triangle might look something like this. Now, I also told you guys yesterday, it doesn't matter which vector we draw first. So your triangle might look like this, or your triangle might look like this, where we draw our east vector first, and then our north vector. But you should be able to see that our resultant is the exact same length, exact same direction. Doesn't matter which way we draw this, okay? So the most important part is being accurate. Now I'm just going to use this first triangle for simplicity's sake. Now that I have my triangle, I am going to take my ruler and I am going to measure my displacement. So this was my step 2. My step 3 is actually measuring the displacement, my resultant. So my magnitude is how long it is. So get your rulers out and measure how long your resultant is. And I really hope we can be super accurate with this. Okay, so you should measure it to be about 5 centimeters. Maybe you measure it off by a millimeter or 2. Okay, maybe we want it to be 5.0 centimeters to be super accurate, but it should be around 5. Now, we're also going to measure our angle. Okay, we measure direction. So the angle we are going to measure, if we look at our previous question, is the starting point. Okay, so your angle is this one right in here that's at our starting point. So you're going to get your protractor out, and you're going to place your protractor to measure that angle at the starting point. That is a really bad protractor, I apologize. But you're going to get your protractor out and set it on your triangle like this to get the angle. And your angle to 1 centimeter, or I guess 1 decimal place, should be around 53.5 degrees. Now we measured it from our north vector towards the east. So if we draw this out in compass point, it is north 53.5 degrees east. Okay, now we are going to combine this into our final answer. So that is our step 4. Step 4 is our final resultant. Now, I'm looking at this question, and I think I forgot to do something. What I forgot to do is convert our centimeters back into blocks. I forgot to do that in our previous question too. Silly me. 5:21 on a Wednesday. I am tired. This should convert back to blocks. That's from our previous question. We had 1 centimeter equals 1 blocks. Just make sure that your final answer has the unit from the question. So it should just be 10 blocks. So if I go back to our actual question, we convert that back to blocks. So we have 5 blocks. And we want to just make sure we have proper least count. So if we look towards the question, we have accurate to the ones place, accurate to the ones, accurate to the ones. So my final answer, I'm going to be accurate to the ones place. I'm at 5 blocks. That is accurate to the ones, so I'm all good to go. Now my direction I'm going to include is north 53.5 degrees east. And that is my final answer. Again, if you love me, if you care for my sanity, circle or box that answer for me. Okay, now if we were to do this second triangle, okay, we would see a similar but slightly different answer. We would still be looking at that angle, but now instead of north 53.5 degrees east, we would have a slightly different angle, okay? Our angle would be, oh, let me do some math here. I can't do this in my head. 53.5. Our angle would be east, 36.5 degrees north. That would still be correct. Now, the reason for that is if I'm just expanding and explaining more stuff to you guys. If we think of our axis like this, okay, and we had our vectors. We drew out our vector going north 4 centimeters, and we drew out our vector going east 3 centimeters. We have seen this before when we were doing vector addition. Our resultant vector would be at the tips of these going in this direction. Our resultants we should see are the exact same. Now, if we calculated with our very first triangle and we got this angle inside here to be 53.5 degrees, and then if we use the second triangle, we would get 36.5 degrees. That is the same thing. They are in the same axis. We are just measuring from a different axis point. As long as both of these numbers add up to 90, which is how much this quadrant is, we are all good to go. Okay, so I hope that kind of makes sense. Okay, taking both those triangles, drawing one this way, one this way, the angles are the same, you're just measuring from a different axis point. As long as they add up to 90, you are good. Okay. All right, I am tired of blabbing. You have finished sample problem B and C, and now it is time for you guys to get to work. So, you have a worksheet. This is what your worksheet looks like, okay, in your blue booklets. This is the top of that page of your vector addition assignment. What I want you to do is work at this and complete this. So get out a piece of loose leaf. You're definitely going to need loose leaf to do all these drawings. You can't just do it on here. And go through the steps I just went through with you. Have your scale factor. Make sure you're only drawing 2 vectors, because you can see here in this question and this question, you're gonna have to combine some vectors. And you're only using protractor and ruler. Okay, I know a lot of you are probably thinking in your head you can do this using the Pythagorean theorem. Not yet. We are only using protractor and ruler for this part. You only have to do the top half of this assignment. Okay, so you should have a good half an hour left of class, hopefully, depending on where you guys got the day before, but you need to complete this vector addition assignment. Okay, oh, there's my husband. All right, I hope you have a great weekend. I will see you guys all Monday, and please be good for the sub. Thank you so much, guys.